Hi everybody. In this section, we are going to learn how to find the multiple integrals. In multiple integrals, we have two types of integrals that we are going to discuss in the sections. And today we are going to discuss how to find out the double integral. We have two integrals, that is double and triple integrals. Double and triple integrals. In the lower sections, you have find out how to find out the single integral. Okay, single integral. And in this coming sections and in this section, you are going to find out how to find out the double integral and how to find out the triple integral. Okay, so all the three are nothing but the multiple integrals. Now, what is a double integral and how to find out the double integral for different types of functions? Now, double integral. If f is defined on a closed and bounded region R in xy plane, then double integral of f over R is given by double integral of f of x comma y into d into capital A, and which is nothing but limit of norm of del tends to 0, summation of I is equal to 1 to n f of xi into yi into, that is nothing but delta ai, and provided the limit exists. If the limit exists, then f is integrable over R. The expression is called double integral and it indicates f of x comma y in the first integrated with respect to x, and the resultant is then integrated with respect to y. As we are referring with double integrals, we should have two variables here, x and y. Now, here the cases arises. Okay, that is double integral of f of x comma y into dx into dy we have. Now, the limits a, suppose b, c, d we have. Okay. Now, based on the type of the limits a, b, c, d, there are three different types of in double integrals. In the first case, a, b, c, d are all constants. The first case will take a, b, c, d are four constants. In the second case, we'll take c and d as variable limits and a and b as constant limits. In the third case, we don't have any integral limits are given in the question. Only the region of integration is given. Double integral of R is given. Then how to find out? First, we have to find out the limits. Then you have to go and calculate the double integral of that type of function. So three varieties we are going to discuss here. Okay, I'll repeat once again. There are three cases arises in the double integral. That is, the cases arises due to the difference in the values of a, b, c, d, which are the limits given in the question. If all the values a, b, c, d are constants, then that it is of first case, which is very simple. In the second case, if one of the pair, that is c, d, is given as variable limits and a, b are given as the constant limits. That is the second case. In the third case, he won't give any limits, a, b, c, d. He'll give the region of integration. Then you have to find out the values of a, b, c, d. Then go with the problem. That is the third case. So all the three cases we are going to see in the double integrals. Now, just multiple integrals, double integrals. When y1 and y2 are the functions of x and x1 and x2 are constants, then f of x comma y is first integrated with respect to y, keeping x as fixed between the limits y1 and y2. Then the resulting expression is integrated with x within the limits x1 and x2. What I mean to say that, suppose if I have integral of 1 to 3 and 2 to 4. Okay, x y into dx into dy. Then what are 1, 2, 3, 4? These are all constants. So in this question, he has given all the four limits as constants. So now we'll get it out. what these limits, to what variable these limit 2 and 4 refer to, and to what variables that 1 and 3 refer to. 2 and 4 refer to the variable that is x. The internal part is first have to be integrated, then we have to take the external part. So these are the values of x and these are the values of y. Okay, so always if all the 4 are constant, the first one is nothing but the values of x variable, that is first which is taken dx, and the second variable is the second limits are for the variable, the outer the derivative which has given dy. Okay, where 1 and 2 are the lower limits and 3 and 4 are the upper limits. So that is how we have to do the problem. Now here you see, okay, y is equal to integral of r into f of x comma y into dx dy. So integral of x1 into x2, integral of y is equal to phi 1x and phi 2x f of xy dy dx. Okay, then the second case, in the second case what we'll take, we'll take the integral or double integral. The second case I'm just telling, suppose 1 and 2 are there and x and x square are the limits, x into y square dy dx. Okay, now what I have taken, in the first case I have taken the variable limits, in the second case I have taken the fixed limits. Okay, what do you mean by variable and fixed limits? Fixed limits are nothing but the constant limits, constant values, and variable limits are nothing but the limits are in the form of x or y. Okay, so here are they. Now to what variable they may, how many types of variables are there here in this question? He has taken 2 variables. As they are in terms of x, there will be for y. So these are the values for y. So first I have to integrate with respect to y. Then everything will be converted to x. Then you start integrating x value. I'll repeat once again. Now you have the integral x to x square. Okay, he won't give anything. We have to first check whether to what variable this belongs to. As they are in terms of x and x square, this will be for the limits for y. Y is equal to x and y is equal to x square, x into y square dy dx. So first we have to integrate with respect to y, convert everything in terms of x, then it will be converted to single variable. Now double integral is reduced due to single integral. Now in terms of x, then you integrate with respect to x. So that is how with the limit, when the limits are given, we have to choose the variable limits in the correct for the correct variable, and because he may maintain any dx dy dx one at the same, so we have to first justify ourselves to what variable does the limits belongs to. So these 3 are the different types of types that we may get in double integrals. Now I'll do one problem. Now you see, evaluate double integral of limits from 1 to 3, 1 to 2, 1 to 3, x y square dx dy. Now first to what variable they belongs to, you have to write, that is integral of, as of all the 4 are constant, the first one belongs to x and second one belongs to y. So y is equal to 1 to 2. Now open the bracket, integral of x is equal to 1 to 3. Okay, x is equal to 1 to 3. I'm doing x first. So x into dx. Okay, x into dx. Close the bracket into the remaining y square value into dy into dy. So first I'll do with respect to x, because the first part I have with x here he has given. You have to follow the order here. This is 1 and this is 2. Okay, so x is nothing but x square by 2. X square by 2. Apply the limits for x square by 2. Okay, x square 9 minus 1 by 2. So which is nothing but 8 by 2. You put it outside. Now everything is converted in terms of y here. So integral of y square into dy, from integral of 1 to 2 y square into dy. So what is integral of y square? Y cube by 3. So from where to where the limits are taken? From 1 to 2. So y 4 by 3 into 8 minus 3, which is equal to 4 into 7 by 3, which is equal to 28 by 3 in simple manner. So always remember that whenever all the 4 are constants, you just to follow the order. Okay, if one of the pair of the limits are variables, then there is no need to find out the order. You have to find, you have to see what variable it is, the limit is, to what variable they belongs to. So like that we have to do the problem. Now, here I have taken the second example, integral of 0 to 2, integral of 0 to x y into dy dx. Okay. Now, here first thing we have to write to what variable they belongs to. From the first limits are given as 0 to x, and the second limits are given as 0 to 2. Okay. As they are in terms of x, they will be for the values of y. So they are the values of y. So they are the values of y. So y is equal to 0 to x, and y is equal to 0 to y is equal to 0 to x, and x is equal to 0 to 2. So y into dy. So what is the integral of y? That is nothing but y square by 2 from 0 to x. So wherever y is there, you just substitute x is the high upper limit. Upper limit has to be, this is the upper limit and this is the lower limit. Okay, lower limit. So first you have to apply the upper limit. So wherever y is there, you just substitute x. So x square minus 0. So x square into dx. Integral, now everything is converted as single variable here. Okay, single integral. Here we have double integral. We have changed the y in terms of x, and we have converted the double integrals to single integral. So single integral x square into dx, and which is equal to x cube by 3. So x cube by 3. Again you substitute the limits for x. That is upper limit is 2 and lower limit is 0. So 1 by 6. 8 minus 0, which is equal to 8 by 6, which is equal to 4 by 3. So this is how we can do the double integral when one is variable and another one is a constant. So let's see further. Let's look into the third variety of problems that we have here. Okay. The same problem is repeated, 0 to 2, integral of 0 to x, y into dy dx. Okay, so same thing. Now we'll go for the next equation, integral of 0 to 5, integral of 0 to x square, x into x square plus y square into dx dy. Okay, again the question arises. First we have to write to what variable the limits belongs to. Integral of 0 to x square. As they are in terms of x square, they belongs to y. So the first limits are for y. And what about to what variable the next is limit? The left out variable is x is equal to x. So 0 to 5 represents the limits for the variable x. So first we have to give clarity to what variable the limits belongs to. Then we have to go to the problem, right? So I've told that the first variable of with respect to y. So we have to integrate with respect to y first. Okay, x into x square plus y square is given. Okay, x into x square, that is x cube. X into x square, that is x cube, plus x into y square. X cube into integral of y dy. So what is y dy? That is nothing but y. Okay, I'm sorry. X cube into integral of dy, which is nothing but y, plus x into y square, integral of y square, that is y cube by 3. So integral of y is equal to 0 to x square dx. So x cube into apply the upper limit, that is x square plus x into x square whole cube by 3, which is equal to x to the power of 5 plus x to the power of 7 by 3. And everything is converted in terms of single variable, that is x. Now we have no more the double integral. The double integral is reduced to single integral. So integral of x is equal to 0 to 5, x to the power of 5 plus x to the power of 7 by 3. Now it can be written as, what is the integral of x to the power of 5? That is x to the power of 6. Which formula that we have following here? X to the power of n plus 1 by n plus 1. That is the integral of the simple formula x to the power of n dx, and which will be equal to x to the power of n plus 1 by n plus 1. This is the formulas mostly we are following here. So x to the power of 6 by 6. plus x to the power of 7. X to the power of 7 means x to the power 7 plus 1, which is equal to 8. 8 by 8 from integral 0 to 5. So add everything. So the final answer is 5 to the power of 6 by 6 plus 5 to the power of 8 by 24. So this is how we can find out the value. In the value for double integral in case of one is variable and another one is a constant. So let's go for the next question. Now here the third variety. What is the third variety? Already we have done two varieties. In the first variety, I have taken all the four limits as constants. In the second case, we have taken one as a variable limit and another one is a constant limit. I have done two problems and one is a variable and another one is a constant limit. Now we are taking the third model of questions where no limits are given, just the region of integration will be given. So when region of integration is given, the first duty of us is you have to estimate the limits. Now estimating the limit is not too easy. First we should have a simple idea, basic knowledge of the figures of the different curves. Then it becomes very easy to find out the limits for the given question. Now the evaluate double integral of xy into x plus y into dx dy over the region R bounded by y is equal to x square plus y is equal to x. Okay, to my knowledge I have that the one is a y is equal, what are the two regions he has given? Y is equal to x square, y is equal to x, and y is equal to x square is a parabola, and y is equal to x is a straight line passing through the origin, So the region bounded by these two figures is nothing but from that region we have to take. Okay, y is equal to x square, it is symmetrical about the y axis, so y is equal to x square. Okay, so this is nothing but y is equal to x square curve, and y is equal to x, that is nothing but y is equal to x. Okay, now we have to find out the point of intersections here. Okay, how to find out the point of intersection? And this is the region of integration which I have. This is the region of integration. Okay. This is the region of integration. Now, before going to the limits, first we have to find out the point of intersection. This point of intersection is obviously 0, 0 because the two curves they are touching the origin. So the point of intersection at the origin is nothing but 0, 0. Finished. Now, how to find out the other limit? How to find out this value? Now, from here, you assume this as 2, second equation, this as first equation. From second equation, you try to substitute y is equal to x in the first equation. So x is equal to x square. So x is taken common. X minus 1 is equal to 0, or x is equal to 0, 1. I got the two point of intersection 0, 1. Okay, 0 is already there here. So I'll worry about 1. If x is equal to 1, what about y value? Y is also equal to 1. So this point of intersection is just nothing but 1, 1. So from where to where the x values changes? From x values changes from 0 to 1, and even y values also will change from 0 to 1. If you are taking x as a variable limits, then you can take from 0 to 1. If you are taking y as a variable limits, then you have to take the limits as 0 to 1. This is how. I'll repeat once again. First, we give the overall figure of whatever curves we have. Okay, y is equal to x square and y is equal to x are simple figures and basic figures that we have already faced in the previous sections. Okay, now find out the point of intersection. How to find out the point of intersection? Try to eliminate one of the variable from two equations we have. Even though if you don't have knowledge of giving the curves, just you can find out the point of intersection from the two curves itself. Also, you can find out the limit values. Okay, what I'm going to say, there is no must and should that the graph should be there is not necessary. By taking these two equations, solving these two equations, we can get the limits also. Okay, so y is equal to x square and y is equal to x are the two curves which he has given. Just what I did, I've substituted wherever y is there x in the first equation so as to reduce everything in terms of x. So x is equal to x square. So x into I've taken x as common. X into x minus 1 is equal to 0, or x is equal to 0, 1. If x is equal to 0, what happens? Y is also becomes 0. If x is equal to 1, what happens to y? Y is also equal to 1. So what might be the point of intersection here? The point of intersection is 0, 1. So this is how we got it. Now the next rule of taking the limits are. Now whatever the rules are, first in the first case, if you are taking x as constant limits, okay, if you are taking x as constant limits, then what you have to take y as variable limits. If this is the first case, okay, case 1. In the second case, if you are taking, okay, x as variable limits, then you have to take y as constant limits. This is must and should, you have to remember. Okay, both variables, the question is incomplete, so remember that only one should be a variable limit and another one should be the constant limit. Okay, so what are the variable limits and constant limits that I can take here? Okay, that is a question here. Okay, so I'll take x as a variable, so y as a variable limits. Okay, y from x to x square, okay, and x from 0 to 1. Either this you can do, okay, then the first case. In the second case, even you can also write it as x raises from root y to y, and y raises from 0 to 1. Either of this I can follow here. So it's better to follow because I don't have roots here. So I'll take. Even this is also correct. Even like this also you can do you can choose the limits. So in this way, the region, when the region of integration is given, you can find out the limits. Okay, so many possibilities are there, and both the cases you have to learn, because sometimes some functions becomes very complicated. So in that case, we have to go for the second case also. So this is up. Now what are the question I have given? Double integral of x into x plus y, okay, into dx dy I have given. So what are the limits here? Y is equal to, I have taken from x to x square, and what are the x limits? X are taken from 0 to 1. So first, with respect to what variable I have to do? With respect to what? Y. So I'll change these two. I'll put this as y and this as x, because first thing I have to do with respect to y, then I have to go for x value. Okay. So first I'll integrate with respect to y, then I'll go for the y value. So doing that, and from here onwards, it's same as we have done in the previous questions. So the answer for this is 3/56. Now, for the evaluation of integral, first we integrate with respect to y. I have taken x square to x, y is equal to x square to y is equal to x, then with respect to x from 0 to 1. Now, what is the answer? How we got it? Integral of x is equal to 0 to 1, y is equal to x square to x square y plus xy square into dy dx, and which is equal to x is equal to 0 to 1, and x square into y square by 2 plus x into y cube by 3, from raises from x square to x. So wherever y is there, you just substitute x square so that it is completely converted in terms of single integration, and happily you can do the solution problem. This is how we can do. And the next problem is evaluate double integral of xy dx dy, where R is region bounded by x-axis and x is equal to 2a, and y, and the curve x square is equal to 4ay. Okay, so how to give this? What is x-axis here? This is x-axis, and x is equal to 2a. Just plot at x is equal to 2a. I'll put a straight line here. Okay, x is equal to 2a, and a parabola x square is equal to 4ax. Okay, so the region bounded by these two. Now this is a region bounded region. This is the R region which he is referring, and this is 0, 0. Got it? And this is 2a, 0. This point of intersection is 2a, 0. Just you have to find out the point of intersection of x is equal to 2a, and the x square is equal to 4ay. So the line x is equal to 2a and the parabola intersect as 2a, 0. So this is a point B, that is 2a, a. Okay, this is a point A and this is a point 0. So the region of integration is AOP is the region of integration. Got it? So this is a. Now what is given integral is double integral of x into xy. He has followed a simple integration x into y, but only the limits are very complicated. Okay, we'll now let us fix with y, and x varies from 2 root ay to 2a. 2 root ay to 2a, because on this parabola, what is this parabola? X square is equal to 4ay. So how to find, give the value of x here? X is equal to 2 root ay. 2 root ay. So 2 root ay, then y varies from 0 to a. Okay, y varies from 0 to a. Now, hence the given integral can be written as y raises from 0 to a and x raises from 2 root ay to 2a and x by dx dy. Okay, first with what variable I have to integrate it? We have to integrate with respect to x here. So, integral of x dx. What is integral of x dx? X square by 2. Now, it's a time to substitute limits for x. So, from upper limit is 2a and lower limit is 2 root ay. Substitute the limits. I got the answer as 2a square minus 2ay into y into dy. Y is equal to 0 to a. So expand everything and now you start integrating with respect to y. I don't have y variable here, so yeah, I'll take it from here y. Integral of y is y square by 2 and integral of y into y, that is y square, that is nothing but y cube by 3. So a to the power of 4. No? So wherever y is there, you substitute a because you have upper limit as a here. So a to the power of 4 minus 4a to the power of 4 by 3, which is equal to 3a to the power of 4 minus 2a to the power of 4 by 3, which is equal to a to the power of 4 by 3 is the answer. This is how. Now, sometimes the question arises in the polar form also, even because till now whatever examples I have taken in Cartesian form. In the Cartesian form, f of x comma y is a Cartesian form. If the given question is in terms of r comma theta, it is in polar form. So the double integral will also be there in the polar form also. So well, let us take one example with the polar form. Okay, where x is equal to r cos theta and y is equal to r sin theta. The relationship between the Cartesian and the polar form, because some will feel very easy to find out the integral in polar form rather than the Cartesian form. Sometimes the question becomes very complicated when you do with in the Cartesian form. So in that case, it's flexibly you can convert that to polar form and find out the answer. So for that case, we have to learn both the Cartesian and polar forms. Okay. Both fields are very familiar fields, and finding out the position, the point in the space, where in the Cartesian way it's only magnitude form, the polar form is there is a magnitude in the angle form you have. Okay, so I have taken one example, integral of 0 to 1, integral of 0 to pi by 2 r into sine theta d theta dr. Now there is now what variable are two variables are there, r and theta are there. Now r you have is nothing but 0 to 1. R here is given as 0 to 1 because these are magnitude. Wherever angle is there, that they are meant for theta, the variable theta. So there is no confusion in polar form, just like Cartesian form. In Cartesian form, it will be confusion. You have to find out you have to follow the order here. Here there is no need to follow the order. Whatever the values are given in terms of angle, they are meant for the theta, and the rest is nothing but the magnitude. They are meant for r. So r into sine theta. Integral of sine theta is minus cos theta, and upper limit is pi by 2 and lower limit is 0. So cos pi by 2 minus cos 0, and cos pi by 2 is 0 and cos 0 is 1. So minus of minus 1, minus of minus plus, r into 1 is r. So integral of r dr, that is r square by 2, which is equal to half. So the half minus 0, the lower limit is 0 because upper lower limit of the r is 0. So it just you can find out the value, that is half. So very easily you can find out even in the polar case also. Okay, so I'll repeat once again. When the question may be in Cartesian form or polar form. In polar form, if the limits are given in terms of angle, then they are meant for theta, and the limits are given in terms of magnitude, they are meant for r. So easily you can differentiate the limits for what variable there, because you have only two limits, that is for r and theta. So easily you can differentiate to what variable the limits belongs to. This is how the double integrals are done for the Cartesian and polar form in different cases. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.